Hi, here we are going to explore some essential ideas of chemistry. The content is derived from this textbook, written by Flowers, etc. It's an open textbook. It's licensed under the Creative Commons attributions. The first question is why we need to study chemistry. Knowledge of chemistry is essential to understand a wide range of scientific disciplines. This diagram shows just some of the interrelationships between chemistry and the other field. Chemistry is here. It's related to chemical engineering, material science, nanoscience, nanotechnology, chemical physics, mathematics, computer science, nuclear chemistry, physics, geochemistry, environmental science, biochemistry, molecular biology, toxicology, medicine, biology, food science, environmental science, agriculture, geochemistry, geology, earth science. So the knowledge of the chemistry is essential to understand a wide range of scientific disciplines. This is important. The scientific method. Chemistry is a science based on observation and experimentation. Chemistry often formulates a hypothesis, a tentative explanation of observations. The law of science summarizes a vast number of experimental observations and describe or predict some facet of the natural world. Theory is where a substantial, comprehensive, testable explanation of a particular aspect of nature. Here, this figure, the scientific method follow a process similar to some shown in this diagram. All the key components are shown in roughly the right order. Scientific progress is seldom need and claim. He requires open inquiry and reworking, research of questions and ideas in response to finding. So here we have observation and curiosity first, then form hypothesis, make prediction. Based on this, next we will perform experiment, make more observations. The result, if not consistent with the prediction, we will come back to form hypothesis and make prediction, and next perform experiments. This is a looping here. If fortunately the results are consistent with prediction, we go to the next step, contribute to the body of knowledge. Okay, then further testing does not support the hypothesis. We come back here and come back here to form hypothesis and make prediction again, and in this loop. From here, we have two ways to go. If much additional testing support hypothesis, hypothesis becomes theory. If much additional testing yield constant observation, observation become law. So this is a diagram showing the scientific method. The domain of chemistry. Chemists study and describe the behavior of matter and energy in three different domains: the macroscopic domain, the microscopic domain, and the symbolic domain. The macroscopic domain is familiar to us. It's the realm of everyday things that are large enough to be sensed directly by the human sight or touch. The microscopic domain of chemistry is almost always visited in the imagination. Micros also comes from Greek and means small, Some aspects of the microscope domain are visible through a microscope. The symbolic domain contains the specialized language used to represent components of the macroscope and the microscope domain, such as chemical symbol. Here is an example. The figure A is moisture in the air, iceberg, and the ocean represent water in the microscopic domain. At the molecular level, microscope domain, gas molecules are far apart and disorganized. Solid water molecules are close together and organized, and the liquid molecules are close together and disorganized. The figure C here. Here the formula H2O symbolizes water, and the GSL symbolized his face. Note that the clouds are actually comprised of either very small liquid water droplet or solid water crystal. Gaseous water in our atmosphere is not visible to the naked eye, although they may be sensed as humidity. So in this figure, we can see here is the microscope domain, here's microscope domain, and here, these are the symbolic domain. The above content is derived from this open textbook and is licensed under the Creative Commons. Thanks.